Hello again. Here we go with 5.2. Okay, 5.2 talks about converting between two quantities. So if I sent you to the store to buy 24 eggs, right, which is 2 dozen, I could say to you, could you go to the store and pick up 24 eggs? And you say, okay, I'll be back in a minute. And if they're $2 a dozen, you say, okay, that cost you $4 because I just got you 2 dozen eggs. Or if I said to you, can you go to the store and buy me 2 dozen eggs? It'd be the same thing. You'd run down to the store, you'd give me 2 dozen, you'd bring back, and you'd say it's $4. Both of those are telling me about the same amount of the item that we're talking about. In this case, eggs, 2 dozen or 24. It's the same thing. I want to be able to do the same thing talking about the number of something, which in this case is going to be big N. Okay, big N is the number of particles, right? Whether it's atoms or molecules. And little n, which is the number of dozen. So if I was talking about golf balls, I don't play golf, but I said to you, if you have 4 dozen golf balls, how many golf balls do you have? Most of you would say 4 dozen. Well, that's 48, right? And you may be able to do it in your head, do it really quickly, and it'd be a no-brainer, right? But in your head, what you've done is you have taken the number, which is the number of dozen. N is the number of dozen, times what is our definition of a dozen? 1 dozen is the same as 12 eggs, right? So if I know that 12 eggs is equal to 1 dozen, so if I multiply this times 12 eggs divided by 1 dozen, because 12 eggs is the same as a dozen, when I multiply my number of dozen, which is 4, times the number of eggs in 1 dozen, the dozens cancel out in the numerator and the denominator. Anything that's in the numerator and denominator will cancel itself out, and I'm left with an answer which is here in eggs. And to get the number now, if I take my 4, if I take my 4 and multiply it by 12 eggs per dozen, I will get my number of eggs. So I'm going to take my 4, which is 4 dozen here, 4 dozen times 12 eggs per dozen. The word dozens on the top and bottom cancel, and the math says take 4 times 12 and divide it by 1, right? 4 times 12 divided by 1, which is 48. So that gives me a very simple model that works in a lot of situations. If I said to you, let's find a blank workspace here. If I said to you, I need you to go and get 6 dozen pencils, right? Exams are coming up and I need 6 dozen pencils for exams. They say, well, how many pencils is that? Well, I'm going to have 6 dozen. I'm going to multiply it by, I know that 12 pencils is the same as 1 dozen, right? So this divided by itself is 1. So I'm multiplying my 6 dozen times 1, which is going to give me 6 dozen. Oh, but now I have to look at what's happening. The units on the top and bottom disappear, and I now have 6 times 12, which is 72 divided by 1, 72. And the units that are left over, remember, this one's gone, I'm left with a unit which is pencils. So if I've sent you to the store and I said, get me 6 dozen pencils, I wonder if that's enough. How many 6 dozen pencils? You'd say, oh, well, 6 times 12, because 12 pencils is a dozen, right? We all know that 12 is a dozen. We also now know that a mole is this number 6.02 times 10 to the 23rd. So instead of getting 4 dozen of something, if I ask you to get 4 moles, so let me do a bit of erasing here. I'm erasing my, oh no I'm not. Okay, if I have 4 moles of carbon atoms, how many carbon atoms do I have? Well, I'm going to take my 4 moles, just like I had 4 dozen up here. I now have 4 moles, and I'm going to multiply it by 6.02 times 23rd atoms is equal to 1 mole. So what I've now got is 4 moles times 6.02 times 10 to the 23rd atoms is the same as 1 mole. Right, that's by definition. Again, remember this number, Avogadro's number, is on your periodic table at the bottom of the periodic table, so you don't have to remember it. And the moles on top and the moles in the denominator cancel out, and I end up with 4 times 6.02 times 10 to the 23rd. The moles are gone, I'm left with atoms, and what I end up with here for my answer is 2.41 times 10 to the 24th atoms of carbon. Okay, so the question was, how many? Calculate the number of carbon atoms in 4 moles. Well, again, if I had 4 dozen carbon atoms, I'd have 48. If I don't, I have 4 moles of carbon atoms, so I have 2.41 times 10 to the 24. Now, to do this equation, to do this mathematically every time, we've come up with a mathematical equation. Just like we know pi r squared for a circle, for the area of a circle, we have an equation that works every time, and it's going to be a nice practical way to do this math, to figure out how many of something there are if I know the number of moles. So if here's my formula here. Again, this is written for you at the bottom of your periodic table. Actually, maybe at the top of your periodic table. I haven't got one at home. There's your formula. And I've got 3 variables. My variables are the number of whatever it is I'm talking about. So in this question here, I was talking about carbon atoms. And the question is, how many carbon atoms? So my unknown here is unknown. What I do know is that I had 4 moles of carbon atoms. Little n is the number of moles. Big N is the number of particles, and little n is the number of moles. And then my last piece for this formula right here is Na. Na is Avogadro's number, right? It's a number that we're going to use over and over and over again. And Avogadro's number is over here, 6.02 times 10 to the 23rd particles per mole, whatever the particle we're talking about. Up here it was carbon atoms, right? So particles per mole. So to do this equation, I now have one unknown, which is big N. I have 2 knowns. One is always known, which is the Avogadro's number. Okay, Avogadro's number is always at 6.02 times 10 to the 23rd. And if I want to solve for the number of particles, big N, it's equal to little n times Na. 4 times 6.02 times 10 to the 23rd, which is what I have up here. Right, and it gives me the final answer, which is big N. Now I can also work the other way around. Right, if I said to you, I'm going to have 96 people here, I'm going to have 108 people here tomorrow for a party, and I want to make sure that everyone gets a slice of pizza. So how many slices do I need to have for my 108 people? Right, how many slices? Now, okay, so I know that's 108. But the pizzeria doesn't sell them by the slice, they sell them by the pizza. And a pizza is 12 slices. So let's say if I have my 108 people coming, I could figure out the number of pizzas. Because I know what a pizza is, it's 12 slices. If I know that a dozen is 12, I can figure out the number of golf balls I have. If I need 36 golf balls, how many dozens do I need? If I go to the store and they sell them by the dozen, how many dozen do I need to buy? How many boxes with 12 in each? Right, with a dozen in each, I'm going to take my number, big N, which is the number of golf balls. Let me erase this here. I don't have much working space on this screen. I'm going to have to figure this out, but it's a work in progress. So my number of golf balls is 36. The unknown here is how many dozens. And my conversion is my 12 dozen, my dozen conversion. 1 dozen equals 12. Okay, similar to Avogadro's number. Avogadro's number is 6.02, and a dozen is 12. So, if that's the case, I can now figure out little n using my formula from up here, right? The formula basically allows me to calculate either of these unknowns. Okay, if I want to solve for little n here now, and I know this variable, and I know this variable, I can solve for little n by taking the NA from here and bringing it down to the denominator on both sides. What I'm going to basically do is divide both sides. Let me clean my working space up here. It's getting a bit messy. I'm going to take this side and divide it by NA. And I'm going to take this side and divide it by NA. Because whatever I do to one side, I have to do to the other side. Oh, but on this side, on the right side, I have NA over NA, so these two are going to cancel out. I'm going to be left with just N on this side, little n. And on the left side, I get big N over NA. So what that's really telling me is that little n is equal to big N divided by NA. Right? Little n is equal to big N over NA. Now, all I've done is I've rearranged my basic equation that I had up here to solve for a different variable. So notice what I've done is I've just taken the NA from here down to the denominator on this side. Right, whatever's on one side, I'm going to switch to the denominator on the other side, and I'm left with little n on one side and big N over NA on the other. So if I want to solve for this question down here now, if I want to solve for my how many dozens is 36 golf balls, well, I'm left with little n as my unknown here. So little n is equal to big N over NA, or over dozens, I guess. And in this case, I know that big N is equal to 36. NA is equal to, or dozens, sorry, this is dozens, is equal to 12. And little n here is equal to 36 over 12, which equals 3 dozen. So you're going to go to the golf store and buy 3 boxes of a dozen golf balls, and I'll have the 36 that I need. Now, let's switch this now to my, instead of doing golf balls, let's go back to atoms again. So if I told you that I needed a mole of carbon, I'd say, or I need this many atoms of carbon for a chemical reaction. Okay, here's the question here. How many moles are in 1.0 times 10 to the 24th atoms? Right. How many dozen are 108? Right. So I've got a number of things on this side, and I'm trying to find the number of moles, little n. So when I'm doing this question now, I'm going to look at the information in the question. The question asks how many moles, so I'm looking for little n is my unknown. I'm told the number of atoms, which is big N. Big N here is 1.00 times 10 to the power of 24 atoms. And I also need to solve for little n. Let's go back up to here for a minute. I can see that little n is equal to big N over NA. So if I say little n is equal to big N over NA, I'm going to take my 1.00 times 10 to the power of 24. Oh dear. I don't know what I've just done. 1.00 times 10 to the power of 24. And divided it, 1.00 divided by 6.02 times 10 to the power of 23. Okay, and I believe that when I take this number and divide it by Avogadro's number, I get 1.66 moles. Now, there's a couple of sample problems here. I'm going to do them separately, and I will post them as separate solutions to sample problems for 5.2. Okay, I hope that makes sense. If not, maybe after the samples, it will make more sense. And once you've worked through the 2 sample problems, I'm going to ask you to try the practice problems in our